Okay, so determine whether or not the indicated binomial is a factor of the higher degree polynomial. Explain why or why not. Well, in order to figure that out, we have to do division. But before we can do that, we have to figure out what we're going to be dividing that polynomial from. And you do that by taking the supposed root that we're testing, and you set it equal to 0. And you just find that out by subtracting 2 from both sides. Therefore, x equals -2. And so that is what we will be dividing the polynomial from, because that is what x is. And then we take the coefficients in front of the x, which is 1, 3, -2, -8. Yeah, you have to carry over the signs, and because that doesn't have coefficient, it's just 1 by default. This is synthetic division. We're doing this because it's easier to do than long division is. And for the first thing in a synthetic division problem is you just carry down whatever the first one is, and then you multiply this by what we're dividing from. So then 1 times -2 is -2, and then you add these two things. So that is 1, and 1 times -2 is -2. Add those both together, it's -4. And add both those things together, and you get 8, which adds to 0, 8, -8. So then the finished problem is x to the second plus x minus 4. And the answer is yes. It is a factor, and it's a factor because there is no remainder. The last thing you're dividing, the last part of the polynomial, if it equals to 0 when you're dividing, that determines whether or not it is a factor. And if it is 0, then it is, because it divides perfectly. And if it is not 0, if it has a remainder, then it is not perfect, and therefore it is not a factor.